Namaste, a hearty welcome to the second session on Introduction to Euclid's Geometry from 9th Standard Mathematics Geometry section, chapter number 2. How are you children? We hope that you are maintaining very good health and regular in your studies. In the previous and the first session, we have understood the 7 definitions of point, line, straight line, surface and plane surface. Can you recall them, children? Okay. We believe that you have done the activities suggested and answered all the questions given to you. Show it to your teachers and discuss if you have any difficulties. Also share your creative ideas with them. Friends, plane figures like parallel lines, triangles, quadrilaterals. In quadrilaterals we have got parallelograms, non-parallelograms, and finally coming to circles have many interesting properties which ancient mathematicians wanted to prove them theoretically and not practically. And you know what is needed to all this? So, in order to prove the properties, one needs at least a few building blocks to start with. So, among the fundamental properties, Greeks assumed a very few of them without giving any proof, that is, without any discussions, without any debate, without asking any questions, without any doubts in the mind, which are very simple and easy to understand as obvious universal truths. And by treating these a few obvious universal truths as assumptions, as a starting point, as a building blocks without proofs, they could prove the rest of the properties. Okay? Starting with this 23 definitions, Euclid assumed a certain fundamental properties. Properties are nothing but qualities, okay, which are taught in algebra and geometry classes from quite a long time, which are not to be proved. And these assumptions are actually universal truths. Universal truths means true or suitable in every situation and everywhere by everyone. Okay. In fact, this is called as obvious universal truth. Obvious means that which can be easily understood. Okay. This is the plan by Euclid's predecessors. Among the universal truths in mathematics, they have selected a few which are very simple and easy to understand as the building blocks or the starting point, accepted them as true without proofs. Based on these building blocks, they could prove the rest of the properties. Oh, obvious universal truth, they have classified into 2 broad categories, children. Category number 1 is axioms and category 2 is postulate. There is a subtle difference between axiom and postulate. Axioms are obvious universal truth common to all the sciences, whereas postulates are obvious universal truth particular to particular branch of science, like we have now in geometry. To give 2 more examples, in atomic theory, we have 5 postulates about atom by John Dalton in 1803, and another example is kinetic theory of gases has 5 postulates by James Clerk Maxwell and others in 19th century. So, obvious universal truth they have classified into two categories, axioms and postulates. Now, the next question is, what should be the number of axioms or postulates? How many axioms and how many postulates one should have? This is a very, very important question. We shall try to attend to this. The number of axioms or postulates for a topic, for a subject or for a system must be as minimum as possible in number. For example, let us consider a triangle, say it has say 100 properties. So, we can think of two possibilities for these two now, possibility 1 and possibility 2. Possibility 1 says that assuming out of 100 properties, 95 properties as universal truths and proving the remaining 5, or assuming just hardly 5 properties as universal truth and proving the remaining 95. Which is ideal, friends? Definitely the minimum number of axioms or postulate is the ideal one. So, the criterion for simplicity requires that the minimum number of assumptions should be always considered. So, Greeks have assumed that there are only 7 axioms which are common to all the sciences, whereas for postulates in geometry hardly 5 postulates are sufficient with which we can explain the whole entire geometry. This is how they have thought of. So, 7 axioms and 5 postulates are considered as obvious universal truth for which no proof is given. Based on this, the rest of the properties are proved. Okay. Now, theorems, you have got some idea regarding theorems in your 8th standard classes, are logical consequences of axioms and postulates only. Okay. Consequence means the result or the effect of. So, this is what we are going to realize at the end of this chapter or the course. So, axioms are very, very important because the logic in mathematics rests on them. Logic means the reasoning. So, the entire mathematics depends on reasoning only, it is full of reasoning. So, any mathematical statement can be proved or disproved using the axioms only. Okay. It is so important. So, in this session let us try to understand axioms, that is obvious universal truth called Swayam Siddhagalu. Swayam means Thanagi. The word axiom comes from the Greek word axima, which means that which is thought worthy. Worthy means ಯೋಗ್ಯವಾಗಿರ್ತಕ್ಕಂಥದ್ದು, ವೆರಿ ವೆರಿ ಇಂಪಾರ್ಟೆಂಟ್. ಇದಕ್ಕಿಂತ ಇನ್ನೊಂದು ಉತ್ತಮವಾದ ಅರ್ಥವನ್ನು ಹೇಳೋದಾದರೆ ಮಕ್ಕಳೇ, that which commends itself as evident. Evident means swayam spashta. So, I would like to tell you some more meaning for this word evident. Evident means obvious. Okay? Obvious means very easy to understand, or no need for any kind of explanation, or no need for demonstration. So, demonstration means an act of showing that something is true by giving proof or evidence. That is the meaning of demonstration. And comments means acceptance or approval. Axioma are nothing but the statement which are accepted as very easy to understand and no proofs are required for this. Okay. With all this information, shall we consolidate the concept of the axiom, friends? Okay, here it is. Axiom, Swayam Siddha. It is a scientific statement which is accepted as true without any logical proof and applicable to many branches of science. So, the word logical and proof, let us try to understand very clearly these two new terms, logic and proof now. Okay. So, logic, it is in Sanskrit we call it as tarka. Okay. So, logic means it is the science that deals with the rules and processes used in good thinking and reasoning only. So, the branch of science which deals with reasoning, thinking, the process, the rules, etc. are called as logic. Okay. It is, in fact, it is a Greek word which means logos, means reason. A reason, the word reason is also wonderful. Let us try to understand. So, reason means for an action or an event, finding a cause or giving an explanation or a justification. So, that is ಸಮರ್ಥನೆಯನ್ನು ಕೊಡ್ತಕ್ಕಂಥದ್ದು. ಈ ಸಮರ್ಥನೆಯನ್ನು ಒಂದು ಆ್ಯಕ್ಷನ್ಗೆ, ಒಂದು ಈವೆಂಟ್ಗೆ ಒಂದು ಸಮರ್ಥನೆಯನ್ನು ಕೊಡೋದಕ್ಕೆ ನಾವು ರೀಸನ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ, ಇನ್ ಲಾಜಿಕ್ we discuss with reason and thinking, the process and the rules, all about it. Okay? Yes. Now, from the time we get up in the morning till we go to bed, we will be taking decision for one thing or the other. So, you should know that decision depends on the reasoning. So, in the human mind, so there will be so many reasons coming up, and with the help of reasons only we are able to take some decisions, and this reasoning depends on the thinking. Okay. So, sometimes our decision may be good or average or bad. So, a good decision depends on the scientific reasoning, and the scientific reasoning depends upon broad perspective thinking, and this is called logic or tarka. So, thinking has to be always rational, without emotions, without any pressure or unbiased. Then the decisions we are going to take will be always an excellent decision. So, having understood the meaning of logic, let us now understand the word proof. Okay? Proof. What is meant by proof? It is a step-by-step procedure of establishing the truth of a statement, the validity of a statement. Okay. Let us try to understand the word proof in some more detail. You have some idea about the theorems and proof in 8th standard. Is it possible to recall, friends? Okay, here it is. So, for the property to be proved, we are going to first draw a suitable figure using a scale, compasses, protractor, etc. In the figure, we will observe the sides, angles, diagonals, shapes, area, etc. and record it in the form of a statement called given or data. So, for each and every statement, we try to give scientific reasons which are based on our previous knowledge, experience, like definitions, axioms, postulates, rules, and the previous properties which are already proved prior to this property. So, we make a chain of statements along with the reasons, so that the mind will get convinced regarding the truth of the statement beyond doubt. So, what is proof, friends? So, proof is nothing but these are the step-by-step procedure of establishing the truth of a statement. I think you now convinced about the word proof. Now, let me tell you one more. We will try to understand the word proof still in a better way. So, proof can be said as it is a process that convinces a skeptical adversary. Process means a series of actions or steps taken in order to achieve a particular end, and skeptical means tending to doubt or not to believe what other people tell you. ಯಾವಾಗಲೂ ತುಂಬ ಅನುಮಾನ ಪಡ್ತಿರ್ತಾರಲ್ಲ, ಅನುಮಾನ ಏನು ಹೇಳಿದ್ರು ಅವ್ರಿಗೆ ತುಂಬ ಅನುಮಾನದಲ್ಲೇ ಒದ್ದಾಡ್ತಿರ್ತೀವಿ, ಇದಾಗಲ್ಲ, ಇದು ಹೇಗೆ ಸಾಧ್ಯ ಅಂತಿರ್ತಾರಲ್ಲ, ಅದಕ್ಕೆ ಸ್ಕೆಪ್ಟಿಕಲ್ ಅಂತ ಕರೀತಾರೆ. ಅಡ್ವರ್ಸರಿ ಮೀನ್ಸ್ ಫೈಟಿಂಗ್ ಆರ್ ಕಾಂಪಿಟಿಂಗ್ ಅಗೇನೆಸ್ಟ್ ಕಾಂಪೊನೆಂಟ್. ಇನ್ ಅದರ್ ವರ್ಡ್ಸ್, proof means it is a process that convinces the mind beyond any doubt and which gives total satisfaction to the mind regarding the truth of a statement. Then such a process is called as a proof, friends. Okay. So, here are 9 qualities of an axiom compiled from various dictionaries from my school. So, I could understand this from various dictionaries as axioms as a formal, which means done in accordance with rules or convention. Concise means sankshiptavagi, short and clear with no unnecessary words, popularly accepted. And obvious, which means easily understood, clear and apparent, accepted without questions, a general true statement applicable to all branches, developed for the purpose of constructing a theory. This is a very, very important, in which theorems may be derived by its rules of inference. Okay. So, there are 7 axioms are there as per our textbook. In the book Elements by Euclid, there are only 5 axioms, and axioms are called as common notion. This word notion is very, very important. So, notion means it is nothing but a reflection in the mind of the real object or the phenomenon. Phenomenon is the singular, phenomena is the plural form, which means event or ghatane. So, notion means kalpane ಅಥವಾ ನಂಬಿಕೆ ಅಥವಾ ಅಭಿಪ್ರಾಯ ಅಂತ ಹೇಳ್ಬೋದು. ಯಾವುದೇ ಒಂದು ವಸ್ತುವನ್ನು ನೋಡಿದಾಗ, ಒಂದು ಘಟನೆಯನ್ನು ನಾವು ನೋಡಿದಾಗ ನಮ್ಮ ಮನಸ್ಸಿನಲ್ಲಿ ಒಂದು ಭಾವನೆ ಉಂಟಾಗತ್ತಲ್ಲ, ಅದಕ್ಕೆ ನೋಷನ್ ಅಂತ ಕರೀತಾರೆ. ಸೊ ಹಿಯರ್ ವಿ ಆರ್ ಟಾಕಿಂಗ್ ಆಫ್ ಕಾಮನ್ ನೋಷನ್. ಇಫ್ ಇಟ್ ಈಸ್ ಯೂನಿವರ್ಸಲ್, ದೆನ್ ಸಚ್ ಬಿಲೀವ್ಸ್ ಆರ್ ಕಾಲ್ಡ್ ಆಸ್ ಕಾಮನ್ ನೋಷನ್. ಸೊ ಟು ಕನ್ಕ್ಲೂಡ್, ಎ ಕನ್ಸೆಪ್ಷನ್ ಅಬೌಟ್ something or belief about something can be called as the common notions. The common notions are evidently the same as what we termed as axioms by Aristotle. So, evidently means clearly we can say that common notions and axioms are synonyms, who deemed axioms as the first principles. Deemed means consider, or we can say judge as the axioms as the first principles. First principle means fundamental starting point, or you can say building blocks from which all demonstrative sciences must start. Demonstrative means that which can be proved or can be given evidences. So, whatever the science we discuss in our schools, for everything we are going to give the proof or give evidences. For all those, the axioms must be the foundation, must be the fundamental or the starting point, which we call it as common notions also. So, axioms or common notions or first principles are one and the same. So, axioms are nothing but scientific statements which are accepted as true without any logical proof and applicable to many branches of science. So, let me keep it on this table. With these, we will take up now axiom number 1. Okay. Now, let us try to understand axiom number 1, which states that things which are equal to the same thing are equal to one another. Okay. So, now I would like to give one small explanation for you. If A is equal to B and A is also equal to C, then definitely B is equal to C, or A is equal to B is equal to C. This can be also written like this, in this fashion. If A is equal to B and B is equal to C, then definitely A is equal to C. Axiom number 1 is also called as transitive property, sankramaka guna dharma pravahana sheela sambandha. Okay, here is one example for axiom number 1. Average life expectancy in Luxembourg, which is in Europe, is around 82.2 years, whereas in South Korea it is around 82.2 years. Therefore, what can you conclude from this? We can say that average life expectancy in Luxembourg is equal to average life expectancy in South Korea. Okay, fine. So, this is axiom number 1. So, things which are equal to the same thing are equal to one another. Okay. So, let me keep it on the table. So, let us perform an activity from our life situation in order to understand the next axiom. Here is a physical balance. This is the left pan, this is the right pan, and look at the pointer. Pointer is exactly at the same height, saying that the left pan is equal to right pan in the mass. Now, let us take half a kg, that is 500 grams of sugar and 500 grams of standard mass, and try to place it on either sides like this. Okay. Now, observe, we are adding equal quantities to both the sides, and the pointer says after some time it will come to rest, and now it says that both the sides are equal. Okay. Instead, if we add say 1 kg, that is 1000 grams of sugar to one pan, and just hardly 500 grams to this, see what will happen. It says that both the sides are unequal, the left is greater than the right. So, from this what can you infer from this activity? So, we can infer from the activity that if equals are added to equals, the whole are equal. So, let me take out this half a kilogram of sugar. If equals are added to equals, then the wholes are equal. This is axiom number 2. Okay? Yes. That was axiom number 2. Okay? This can be also called as additive axiom. Now, axiom number 3 states that if equals are subtracted from equals, then don't you think the remainders will also be equal? Okay. So, this can be understood with the help of this once again physical balance. So, let us say that the left pan is equal to right pan, and we say that A is equal to B. So, let us subtract C from both sides, then we will get A minus C will be exactly equal to B minus C. So, this is axiom number 3. So, this is axiom number 3, which states that if equals are subtracted from equals, then the remainders are equal. Okay? So, shall we go to axiom number 4, friends? Okay. It states that things which coincide with one another must be equal to one another. So, here is two line segments, and let us overlap one segment on the other. If they coincide exactly, then we can say that the two line segments are equal in length. There are pair of triangles here. So, let us take one triangle and try to superimpose it on another triangle. Here in this case it is exactly coinciding on the other. Therefore, we can say that those two triangles have the same shape and same area. So, that is the meaning of the axiom number 4, which states that things which coincide with one another must be equal to one another. So, things which coincide with one another must be equal to one another only. So, coming to axiom number 5. Axiom number 5 states that the whole is always greater than the part. Definitely, you know. For example, if you observe this our map, India map, and in this India map, Karnataka is just a part, one of the state of India, and if anybody asks, is Karnataka is bigger or India is bigger, definitely Karnataka is being a state of India, so it has to be a smaller when compared to India. Axiom number 5 states the whole is always greater than its part. Now, coming to axiom number 6, it is quite simple. Things which are double the same things are equal to one another. For example, if A is equal to B, if you multiply both the sides by 2, we get 2A and 2B. Don't you think 2A is equal to 2B? Or we can say m times A is equal to m times B. Therefore, we can say that axiom number 6 can be stated as things which are double of the same things are equal to one another. This can be called as a multiplicative axiom also. So, this is our last axiom, axiom number 7, and which states that things which are half of the same things are equal to one another. Again, if A is equal to B, then A by 2 has to be equal to B by 2 only. So, axiom number 7 is this: things which are halves of the same things are equal to one another. Correct? You understood this? So, here is the list of all the axioms, 7 axioms which I have discussed in this session. Okay, in this second session on Introduction to Euclid Geometry, we have discussed 7 axioms, and in the next session we will discuss the 5 postulates of geometry. Okay. So, can you take down the homework, children? So, these are some of the homeworks. 2x plus 3 is equal to 5. We have to solve for x using the axioms, state the axioms you use for each and every step, write it adjacent to it. Prepare a chart showing all the 7 axioms in different colors in KG cardboard and display it in your classroom. So, with all my best wishes, thank you very much for viewing this video. I am T.K. Prasannamurthy, retired headmaster, Vijay High School, Jayanagar, Bangalore 11. Namaste. Namaste children. Namaste.